Hi students, welcome to the problem solving session on Fourier Transform. Let us see this problem. Find the Fourier Transform of three questions I have given. Let us take this problem. If you find Fourier Transform, what is the formula? Fourier Transform formula is x of omega. So x of omega is equal to integral x of t minus into e power minus j omega t dt. X of t is they have given here. If you substitute x of t value here, the integration will be too complex to solve, right? So we have to use the property of Fourier transform. So which property we have to use? That is the question, right? So see here, these are all the question you see. X of t is equal to 1 by a square plus t squared. This is 1 by t, right? These are all showing some frequency the Fourier transform of some signals, right? So like that it appears. Let us see that, right? We know that e power minus a modulus of t as a Fourier transform of what you call 2a divided by a square plus omega square. So it's like 1 by a square plus t square. The a is a constant that we can remove. So this is like this. So we can go for a duality property. How we know as per duality property, x of t, capital X of t as a Fourier transform of 2 pi into small x of minus omega. What's the meaning? If you know Fourier transform of something x of some signal x of t is x of omega, you can find Fourier transform of capital X of t, that is omega replaced by t, is given by 2 pi into x of minus omega, right? So let me first solve the problem, then you will understand the problem simply. So this is the thing I know, right? K power minus a t has a Fourier transform of 2a by a square plus omega square. But what I want to find is, this is what let us assume, right? So you see this indicates this is x of t, this is x of omega. So as per duality property, capital X of t has, that means 2a divided by a squared plus d squared as a Fourier transform. This is x of omega, so this is x of t. Fine, I replace omega by t as a Fourier transform of 2 pi into small x of minus omega. That means it is x of t, t must be replaced by minus omega. 2, right? X of minus omega, 2 pi into x of minus omega means e power minus a, t must be replaced by minus omega. Now you understand? I know x of t, x of omega, capital X of omega. So if this is x of t, this is x of omega. For capital X of t, this is capital X of t, this is 2 pi into x of minus omega. This is what duality property. Yes or no? So I replace x of small x of t by minus omega, capital X of omega by t. Yes or no? Okay. Now hereafter the problem is simple. You see what this is Fourier transform, right? 2 cancel, right? So what they asked, Fourier transform of 1 by a squared plus t squared. So 1 by a squared plus t squared Fourier transform. Just I bring this a right hand side, it will be, what will be, pi by a e power minus a, modulus of minus omega is plus omega only, no problem. Simple. Now we got it. What is the meaning? This indicates Fourier transform of 1 by a squared plus t squared is equal to pi by a e power minus a mod omega. That's what this equation says, no? 1 by 2 a squared plus t squared as a Fourier transform. This one, I am writing that in the different form. So this is what they asked in the question. Find the Fourier transform of 1 by a squared plus t squared. This we finished. Simple. Let us go to second problem. What is the second problem? X of t is equal to 1 by t. Right, here also, if you substitute in the general formula of Fourier transform, it is very difficult to solve. Right, but we have to find some uh, Fourier transform pair that is matching with this. Right, that we must remember. Otherwise, it is very difficult to solve the problem. I remember one thing. we know that signum of t as a Fourier transform of what you call 2 by j omega. Okay, so here you see this is x of t, this has a Fourier transform x of omega. So what is the thing as per the duality principle? X of omega should be is x of t 2 by jt, right? 2 by jt, this is what will be replaced by, right, what you call capital X of omega. This x of t is equal to 2 pi, right, x x of minus omega. So 2 pi signum of minus omega. This is what I write properly. This is our capital X of t as per the duality principle 2 pi x of minus omega. This x I replace with minus omega. So 2 pi into signum of minus omega. This 2 pi jt. What they ask in the problem? They ask Fourier transform of 1 by t. So simply cancel this 2 will be cancel out this Fourier transform. Right? This j I bring that side. So what will happen? 1 by t. This j I bring this side. Pi j signum of minus omega. This is Fourier transform. So from this what we understand, Fourier transform of 1 by t. That's what this meaning. 1 by t as a Fourier transform of j pi signum of minus omega. Simple. Over. We use the duality principle. Okay. Fine. Next property is next problem. Third problem is 1 by 2 x of t they are given. Okay, write properly. X of t is equal to 1 by 2 del of t plus j by pi t. If you substitute in the formula, it is very difficult to solve the problem. So again, but we know this is like some Fourier transform pair. So we can go for duality principle, right? So what is the thing? We know u of t, the unit step signal as a Fourier transform of pi into del of omega plus 1 by j omega, right? This is the Fourier transform of u of t, right? Now we use duality principle. This is x of t, this is x of omega. As per duality principle, we will solve this. So what we have to do, pi into del of t plus 1 by jt is given by, right, so is equal to 2 pi u of minus omega, right? Now you see x of t as a Fourier transform of x of omega means capital X of t as a Fourier transform of 2 pi into x of minus omega. So x of omega I replaced whatever omega I replace with t. So pi into del t plus 1 by jt. Similarly 2 pi u t replaced with omega. So not x of omega, it's u of minus omega. Right? So u of sorry, the property is x of omega only, right? Okay. Fine. So I replace it 2 pi. Instead of x of minus omega, t I replace with minus omega. So it will be u of minus omega. Fine. So hereafter it's just a simple notation, right? But what they ask in the problem, I have to find 1 by 2 into del of t plus j pi t. So del t is there. So pi has to be removed. So I bring this 2 pi this side. So I divide everything by 2 pi. So it will become 1 by 2 del of t plus what do you call so I divide everything by 1 by 2 pi, right? So divide by 2 pi. So 1 by 2 pi I bring inside, 1 by 2 I keep it outside. So 1 by 2 pi cancel, del of t plus 1 by j pi t. If I divide by 2 pi, it will be 1. So u of minus omega. What they ask, right? So here, this is what we got. But but the question is Fourier transform of 1 by 2 del t j by pi t. But here we have 1 by j pi t. So what we should remove, and moreover it is u of minus omega is there. We want u of plus omega only. So what we have to do is, let us see, we replace t by minus t. So replace t by minus t, omega by minus omega. So what will happen? This will be equal to 1 by 2 del of minus t plus j pi minus, so it will be minus u of omega. If you replace t by minus t, similarly omega must be replaced by minus omega. That we must remember, right? So because both sides we have to replace. So now you see 1 by 2 del of minus t is del of t only. 1 by minus j is plus j. So 1 by minus j is plus j divided by pi t. That gives Fourier transform. It's Fourier transform pair, right? ft, ft. So what's the thing? This indicates the Fourier. So this is the Fourier transform of u of omega is the Fourier transform of this fellow. So Fourier transform of 1 by 2 into del of t plus j by pi t is equal to u of omega. That's it. I hope you understand this concept. If you have any doubt, please ask me in the comment section. I will clarify. Thank you.